Does anybody have any questions over anything? 468, number 15. 472. Wait. What page? Oh, number 17. Okay. 15. Oh, that's what I thought you said. Okay. 16 minus 2c. This look like the one? Okay. 4c squared d cubed divided by c squared plus 8c over 6c to the 5th d. All right, so the operation here between these two rational expressions is division. So whenever we have division, we want to flip the second fraction over. So we'll just rewrite everything. So this is 16 minus 2c over 4c squared d cubed times 6c to the 5th d over c squared plus 8c. All right, now, as far as simplification, we can try and factor, see what factors. Remember, we have 4 different expressions to take a look at here. The top left one, we can do something with the top left, right? Because there's 2 terms up here, and we can pull a GCF out. 2. That'll leave us with 8 minus c. Denominator, that's only a single term, right? 4c squared d cubed. Can't do anything with that. Top right, single term. Bottom right, factor c. So GCF out of the 2 terms. Yep. All right, now remember, because everything's been factored, we have multiplication between, let's say, I'm putting the red dots here. It's all multiplication, multiplication there, multiplication, multiplication. There's even multiplication across the top and bottom, right? So what I'm going to do, just to make this a little bit cleaner, is I'm just going to regroup everything. On the top, I'm going to take my numbers and multiply them together. So I'm going to take that 2 and that 6. I'm going to make a 12. I have a c to the 5th. I have a d. And then I'm going to put that 8 minus c in parentheses. Is that all right? On the bottom, let's see. I have just the 4. How many c's do I have on the bottom? 3 of them, right? So c cubed, 3 factors of c. And then d's, d cubed. And then I have that c plus 8. So the only thing I really did on the bottom was put these 2 c's together, right? Right there. And now what I'll do is I'll try and simplify this. Let me go 12 divided by 4, right? That'll leave me a 3, and the 3 would be up top, right? Okay, c to the 5th over c cubed is c to the 2nd, and that'll be on top also, right? d over d cubed, that'd be d to the negative 2. So I put it on the bottom as a d squared. And then what about those last 2 here? Are they off by a sign? You sure? Well, the 8s are exactly the same. The c's are off by a sign, but the 8s are not. You need the 8s to also be off by a sign. So you need one of them to be negative. So if this was minus 8, we could factor a negative out. If this was negative 8, we could factor a negative out. But since neither one of them, well, they're not opposite signs, that's it. We can't do anything to it. So we just leave it. 8 minus C, and then C plus 8. Now, the book, I'm sure, does not have that answer in the back. They multiplied it out. Okay, so they went ahead and multiplied this times this, got 24C squared, and then multiplied this times this to get plus 3C cubed over the denominator they multiplied through. They probably have CD squared plus 8D squared, or did they leave it factored? Oh, and they didn't multiply through the bottom. See, I don't understand that. Did I miss a minus? Sorry, real quick. That's a minus up top. Yeah, that was a minus. That was just a typo on my part. Is that what you were referring to? Okay, sorry. Yes, if you were on a test or something, if you were to have this, I'd be happy with that. That's fine. Okay, and any other questions? Okay. What we ended class with last time, just to remind you, we were talking about, how do we add fractions? How do we add fractions if they have the same denominator? And that was the easiest case. We just added up the numerators. Here, same denominator, we add them up. Then we said, okay, well, what about if we have two rational expressions that have same denominator? Then we just add across the top. Or even something as ugly as this, where they have the same denominators. Here we subtract. So we have to do this 3x squared and then take away this entire thing. And just remember that when we did the taking away, we had to subtract the entire top, right? So change the signs, yes. All right, and then let's see. So, okay, if we have different denominators, though, we have to get the common denominator. So what we did is we tried to figure out a denominator, that would make both of them match. So like if you have a 5 and a 4, multiply this 5 by 4 on the top and bottom here, you get 20 on the bottom. If you multiply this 4 over here by 5 on top and bottom, you get 20. Then you can put them together. So that was just reminding you how we did it with numbers. And then we did something like this, where we had two different denominators and came through and did our thing. So that's what we're going to pick up with today. We're going to continue doing this. All right. Now, just real quick, the way that I'd like for things to go here, today we're going to do more of this stuff. We're still in section 7.3. And we're going to probably finish it. And then on Thursday, we're going to have a review for our exam. On Tuesday, we're going to have exam 4. On Thursday of next week, we're going to review for the final. And then on, I don't know, it's on your calendar. I keep on forgetting to bring it. What day is our calendar? Let's see here. Let me get in here real quick. Let me see if I can log in. I just want to make sure everyone's aware of when our final is. All right. Oh, you know what? I can go here. Okay, so our next Tuesday, or not Tuesday, next Tuesday we're taking our test, right? We're reviewing for the final. Then we have no class on the 13th, and then on the 15th we have our final from 9:30 to 12:15. Okay? Yep. I don't anticipate it being this long. All right? So Tuesday after that, no class. On the week of finals, you should only meet with your class once. One of the 2 days. Now, remember how I said what I would like to do is offer students a chance to make up one of their lowest or bring up one of their lowest test grades? I was trying to figure out how I was going to do it. Well, I figured out how I'm going to do it. Okay, you're going to take your test on next Tuesday, right? A week from today, you're going to take your exam 4. On Thursday, I'm going to have your results. And on that Thursday, the day that we review for the final, I'm going to want you to tell me which exam, if you want to redo an exam, which exam you want to redo. And what you're going to wind up doing is on the day of the final, this is like almost 3 hours, okay? I anticipate that the final will really only be about an hour, hour and a half, okay? That's how much time you should need for the final. So it's going to be like a normal exam. But then when you finish that, if you wanted, let's say you tell me on Thursday, hey, I'm going to redo my second exam. Then what you have to do is you have to take the final. And then after you take the final, you have to do the exam 2 stuff. All right, so you'll have to do like a double exam that day, which will kind of suck, but that's just the way it is. So the reason why I'm going to do it this way is because I'm going to look at your exam 4 and I'm going to figure out where you stand in the class. And then on the day that you take the final, when you turn it in, I'm just going to look through it real quick to get an idea of where you are. And then we'll have a real good idea of where your grade is right there. And you'll be able to determine whether or not you even want to do the makeup. Does that make sense? Yes. Mm-hmm. Well, yeah, that's a good point. If on this day, Thursday, after you take the final, you say, hey, I want to try and do exam 2, see if I do better on it. I give you a new version of exam 2, and you do worse, then I'm going to take the worst. I'm going to take whatever grade you get that day. Okay, so it's not like you get a free swing at it. I mean, you have to be ready for that exam. You have to be you have to have gotten prepared and feel good about it. So there's a risk involved for you. Okay, good question. But let's just see. I mean, for me, I think you just need to see where you stand after exam 4, because then you'll know exactly what you need going into the final, right? Exactly what you need. Okay, let's continue. So let's try and address these problems again that don't have the same denominators. And let's go with something like well, we'll do this one. A plus 5 over A minus 3 plus 8 over 3 minus A. All right, 2 rational expressions being added together, right? Not multiplication, not division, addition. So for addition, we have to have the same denominators. Do we have the same denominators? No. But does anyone see something here? I have A here, I have negative A here, I have negative 3 here, I have positive 3 here. They're off by a sign, right? So tell me, is this okay for me to do this? A plus 5, I'll leave this one alone, A minus 3. But on the other one, I'm going to pull a negative out and then put, what, negative 3 plus A? Now, what did we say about negative signs on fractions? We can put it, if we have one on the bottom, it can be on the top or it can be out front, right? If I move that negative up here to the 8, then won't these two denominators match? Yes? So it would look like this. A plus 5, A minus 3, plus negative 8 over, now I'm just going to rewrite the bottom. All I'm doing is I'm taking negative 3 plus A, and I'm just reversing the order. Negative 3 plus A is the same as A minus 3, right? The negative that was out front, I moved it up. That negative went up and got attached to the 8 on top. Now, I did that because now the denominators match, don't they? And if the denominators match, all you do is you take the numerator here, and then whatever operation is here, so it's addition, and then this. Go with me on that? Yeah, what do you mean, this operation with that negative sign? I could have put that negative out here and changed that plus to a minus. I could have. But I'm just moving it up to the top because that's also an option. It doesn't matter. Yep. Now, just be careful because let's say this had been a minus up here, right? That was a minus. Then if you take that negative and put it up here, it's going to be a plus now. Yeah, it's really up to you. I mean, either way, it's the same. You just can't put the minus here and here at the same time. Okay, so what am I going to be doing? The A plus 5, and then I'm going to add to that negative 8, which is the same as subtracting 8, isn't it? Adding a negative is the same as subtraction. So this is really minus 8, and then all of that over my common denominator. And what does the numerator turn out to be here? A minus 3, and then over A minus 3, and then this is 1. Because anything divided by itself is 1, right? They cancel out, basically. They cancel. You can look at it as this over this, and they're exactly the same, and they cancel out. Just remember, A minus 3 over A minus 4, those don't cancel, right? Like the A's don't cancel here, because they're not exactly the same. So can't do that. So the answer here is 1. Okay? So I guess the moral of the story on this problem is that if you look at the denominators and they don't appear to be the same right off the bat, but they look really close, just try maybe pulling a negative out and seeing if by pulling a negative out you can get the two to match. That'll save you quite a bit of work. Questions? Yes. Right here. Right here? Yes. Well, what I did was A plus 5 plus negative 8. But plus a negative, right? If I were to write it this way instead, A plus 5 plus negative 8. That's the 5 plus negative 8 is the same as negative 3. When you add fractions, you add straight across, right? If they have the same denominator. Right, if I do 3/7 plus 5/7, then I go 3 plus 5 over 7, right? That gives me 8 over 7. Anybody see any problems with what I did? The reason I'm asking is because this doesn't, hold on a second, 3, let's see, let's check our answer real quick. Let's check this answer, 1. Let's plug it in right here, right here, right here. Or wait, hold on. Scratch that. Having brain fart moment right there. Y'all ever had those? Let me see. The reason why I'm bringing this up is because the book has a different answer. I think the book is wrong. Did I miss any signs? Let me make sure that the book, that I wrote the problem down exactly the way the book. In my book, I don't know if your book has it. Does yours have go for it on the corner there? Wait, hold on, page 475. Look at page 475. There's a go for it there. You see part A? A plus 5 over A minus 3 plus 8 over 3. Oh, I didn't see the plus 1. Okay. All right. I wasn't reading that right. Okay. Let's just leave it alone. Let's just stick with this then. I didn't copy the problem down correctly, but yeah, this part of it is correct. All right. I swear, I think I'm getting old. Starting to slow down. My brain's starting to slow down. All right, let's try something else. I'm going to do the next go for it here. 2y squared minus y minus 6 minus y plus 7 over 3y squared minus 11y plus 10. I can't believe I said let's plug that answer in. That is, right when I said let's plug that 1 in, that is so wrong. I should be ashamed of myself. It wasn't an equation, right? We weren't solving for a variable. We were simplifying an expression. All right, check this out. Ugly, right? We have two rational expressions. We have subtraction, which means that if we want to do this, we have to get the same denominators. And we don't have same denominators, and they're not even really close, are they? They're both trinomials, which I'm happy about, I guess. And they both have y's in them, so I'm happy, I guess, about that. But other than that, what do I do? So remember, the idea was to try and get the same denominators, right? So before you go trying to do anything here, let's factor those and see what they look like factored. So you have to do like an AC method on the bottom left, and then you have to do an AC method on the bottom right. Hopefully they factor. Hopefully they're not prime. So let me try that first one over here. If I did my little XC thing over here, I'd get negative 12. I get 1, which gives me 4, negative 3. Oh, negative 1, sorry, other way around. Negative 4 and positive 3. Agreed? And then you go through your grouping on that. If you go through your grouping on that, let's see, you should get y minus 2, 2y plus 3. Let me just double check this. Y times 2y is 2y squared. Y and that is 3, negative 4 and 6. Okay, so that works. So I'm not showing the rest of that, right? Now on the other one, other trinomial, I'd have to do, let's see, 30 and negative 11. What's that? Negative 6, negative 5. So this will give me y minus 2, 3y minus 5. I'll check it real quick. 3y squared minus plus. Okay. So that's it. Is that okay so far? Now, the two denominators that I have here, we know they're not the same, but there are some similarities here. When we factored them, there are some things in common, right? I have a y plus or y minus 2 and I have a y minus 2. So that much is the same. What's different is that this one has a 2y plus 3, this one does not. This one has a 3y minus 5, this one does not. So remember what we said last class is that in order to get an LCD when you're dealing with rational expressions is basically whatever you have over here that's not over here, you've got to put over here. Or whatever you have over here that's not over here, you have to put over here. So let's just look at this. Y minus 2. Do they both have y minus 2s? Yes. Okay. How about 2y plus 3? Do they both have 2y plus 3? No. This one's missing a 2y plus 3, right? So what I'm going to do is I'm going to insert a 2y plus 3 here. But I cannot just put a 2y plus 3 on the bottom. I must also put a 2y plus 3 on the top. And the reason why I do that is because this is really a 1, right? So I'm not changing the problem. Okay, so they both have y minus 2. They both have 2y plus 3. How about this 3y minus 5? This one doesn't have it, right? Over here? I put it on this side. Now my equal sign's a little too close, so I'm just going to move it. Sorry, I know you don't have a lot, you may not have left yourself enough room, but just you could do it on another line and just rewrite everything. What am I going to insert on this side? 3y minus 5, and then on the top, 3y minus 5. All right, so now what we'll do is we will multiply out the tops. What I mean by that is I have a y here. This y will distribute through both here. Y times 3y is 3y squared. Y times negative 5, negative 5y, right? Over my LCD, which is everything. I'm not going to multiply it out. I'm just going to leave it all like this. Then minus, over here, what do you think we need to do on the right side? Multiply this out. How many terms do I have right here? How many terms here? 2. So if I have 2 and 2, this is a binomial times a binomial. So I want to do like that foiling thing, or expanding it. So I want to do y times 2y, y times 3, 7 times 2y, 7 times 3. So we'll have y squared, 2y squared, plus 3y, plus 14y, plus 21, all over the LCD, which again is exactly the same as the other one. Are there any questions? Couldn't I put that 3y and the 14y together here? That's really a 17y, isn't it? I just did that so you could see that came from the FOIL. All right, now am I allowed to put these two fractions together? Yes, but I have a subtraction sign. So because I have a subtraction sign, it means I want to subtract everything over here, which means it changes the signs of everything over there, right? Now I'm going to do this kind of slow. I'm going to write it out as 3y squared minus 5y, and I want to subtract everything on the other one. You don't need to put this step if you do it. If you just want to change the signs, that's okay. But I'm just doing it to try and help you remember the negative would distribute. If it was plus, would we be doing this? No, we just put plus and be done. Okay, that minus sign has to distribute across this whole thing. So that minus sign has to distribute through here. So let's go ahead and distribute the minus and see what we get. 3y squared minus 5y minus 2y squared minus 17y minus 21 all over all that junk. Anything left to do? How about some like terms on the top? 3y squared and 2 minus 2y squared is 1y squared. 5y, take away 17y is 9, careful, 22y, right? And then minus 21 all over the LCD. That LCD just makes your hand cramp, doesn't it? Having to rewrite it over and over. That's where we are, all right? Now, our only hope for making this any cleaner is to see if perhaps this would factor. Because maybe it factors and cancels with one of these, right? So let's see if we can factor this negative 21 and negative 22. And that's not going to happen. Question? Minus, 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 yes? Minus, minus, minus. All right. So this is prime. This is prime, doesn't factor. We have added the two fractions together. I have a single fraction now, don't I? And so I am done. Not exactly something you would describe as pleasurable, huh? This stuff? It's not real high on your list of things you like to do? Oof, let's look at this one. Yeah, you don't need to multiply it out. You can leave it. How about 10x? Oh, you know what? Let's do this instead. I'll leave that one for your homework. 6x over x squared minus 4. And when I just wrote that x squared minus 4, what did you think? Difference of squares, right? Okay. All right, let's put these three fractions together. Three fractions, right? We have subtraction between them, so we have to have a common denominator. So if we're going to have a common denominator, let's make sure that we have factored all the denominators, so that way we can see what's in common. We just said this x squared minus 4 is a difference of squares. The x plus 2 does not factor. And the 2 minus x does not factor. Those aren't difference of squares or sum of cubes or anything like that, right? No DCFs on those? Okay, so let's go ahead and factor that first one there. X squared minus 4 becomes x plus 2x minus 2 minus 3 over x plus 2 minus 4 over 2 minus x. Anybody see something here? What do you see? Yeah, there's certain parts that are the same, certain parts that are different, right? Like, yeah, good. That's what I wanted you to see. Okay, this right here, 2 minus x, is almost the x minus 2, isn't it? It's off by a sign. So what I'd like to do is I'd like to make those look the same. So I'm going to pull a negative out of that one, and then I'll put the negative, on this one I'll put the negative out front here, and I'll make that minus become a plus. And I'm going to have to rewrite the whole thing. So this becomes plus 4 over x minus 2. So just make sure you're aware of what I did there. I pulled a negative out, which made it negative 2 plus x. And then that's really x minus 2 with a negative out front. So when you pull the negative out, it changes the signs, but then I can flip the order, and it looks like this. And then that negative, I took it and I pulled it out here up front, which changed it to a plus. Is that okay? Now, the reason why that's so nice is because, look, at the denominators, x plus 2, the only one that doesn't have an x plus 2 is this one, right? And then as far as x minus 2s, I have x minus 2, I have x minus 2. The only one that doesn't have an x minus 2 is this one, right? So I really only have two different factors in the bottom, right? X plus 2 and x minus 2. Had I not done this switch like this, then I would have had 1, 2, 3 different factors, and it would have been a little more complicated. So this just saves me a little bit of time and energy. All right, let's see here. I don't like all those colors. Let me get them out of here. X plus 2. Start with that. I have x plus 2 here. I have x plus 2 here. I'm missing an x plus 2 on this one, right? So I'm going to insert it right next to it. X plus 2, top and bottom, x plus 2. That makes it so that every denominator has an x plus 2. Agreed? How about x minus 2s? X minus 2 here, x minus 2 here. I do not have an x minus 2 on the middle one, do I? So I'm going to insert it. Well, where do you insert it? Well, wherever you can fit it, I guess. X minus 2, x minus 2. Now, all my denominators are the same, aren't they? But before I start putting things together, let me go ahead and multiply out the tops. So can you do anything, or do I need to do anything to the 6x? No. Over here, I need to put these two together, don't I? And then over here, I need to put these two together like this. So I'm going to have 6x over my x plus 2 times x minus 2. I'm going to have minus. Now what happens when I distribute this 3 through here? 3x minus 6 over x plus 2x minus 2. Then plus, what? 4x plus 8 over x minus 2x plus 2. It doesn't matter which order you do it, right? They're going to be the same anyway. And then put them together. So I'm going to do 6x. I'm going to take away 3x plus 6, which means it's going to change the signs of those, right? And then I'm going to do plus, which means it's not going to change the signs, 4x plus 8. I'm going to do all that in one line, all right? So I'm going to write out 6x, then what? Minus 3x. Go ahead and do the changing of signs now. Plus 6. Then this minus right here only affects these two. Okay, only those two. And now plus what? 4x plus 8 all over the x plus 2 times x minus 2, which is my LCD. Let's collect like terms. 7x plus 14 over x plus 2 times x minus 2. We done? No. What can we do? On the top, you can factor what out? 7, and you're left with x plus 2, which is over x plus 2 times x minus 2. And these two factors cancel, which leaves you with 7 over x minus 2. Okay, your turn to do some of this, all right? I mean, this is pretty much it. As far as the semester is concerned with material, we're done. There's nothing new, all right? But you need to practice this. We're going to practice it today, and then we're going to practice it on Thursday. Thursday, what I plan on doing is coming in and just having a handout that you just work, all right? That'll be your review. I'll provide the answers to it at some point, all right? I don't think I'm going to work it out in class or anything. I might do a video on my own, but it'll be just in-class work for you to get acclimated to this stuff. All right, you ready? Let's try, well, for your homework, let's go page 476. Let's see, I'd given you up through what, 35? No. 19? I gave you through 19. Okay, so what I'd like for you to do, 35, 39, 43, 45, 47, 49, 53, 61. And for right now, let's get you started on your homework. 39, 47, 53, and 61. See if you can do those 4 problems. Well, see how much of the 4 you can do right now. Anybody need a book? Yeah? So you got about half an hour. Let's see how much you can do here. I believe all of these problems, you have to look for the LCD, right? They don't have the same denominators.